Hey guys, welcome back. So in this video, we're gonna look at SQL injection walkthrough from TryHackMe, which is a very nice room because it gives us an interactive way to do the hacking. It even shows the server side queries and all that things. Okay, so let's dive into the lab. This is gonna be the last, not last, but a long video. So bear with me. Okay, so let's start here. On the task one, brief, SQL structured query language injection, mostly referred to as SQLI, SQL injection, is an attack on a web application database server that causes malicious queries to be executed. When a web application communicates with the database using input uh, users from a users that hasn't been properly validated, this runs the potential of an attacker being able to steal, delete, or alter the customer's data and also attack the web application. Authentication methods to private or customer areas. This is why, as well as SQLi being one of the oldest web application vulnerabilities, it also can be the most damaging. In this room, you will learn what databases are, what SQLi with some basic SQL commands, and how to detect SQL vulnerabilities, how to exploit SQLi vulnerabilities, and as a developer, how can you protect yourself against SQL injection. Okay, what does the SQL stands for? So it's structured query language. I'm going to copy it from here, type in and submit. Let's go to the task 2. What is a database? If you are not used to working with databases or exploiting them, there is probably some new technology to get used to. So let's start with some basic on how databases are structured and how they work. What is a database? A database is a way of electronically storing collection of data in an organized manner. A database is controlled by a DBMS, which is an acronym for Database Management System. DBMS fall into two ramps, relational and non-relational. The focus of this room will be relational databases. So common ones will be across MySQL, Microsoft SQL Server, Access, PostgreSQL, and SQLite. We'll explain the difference between relational and non-relational databases at the end of this task, but first it's important to learn a few terms. Within a DBMS, you can have multiple databases, each containing its sets of related data. For example, you may have a database called shop. Within this database, you want to store more information about products available to purchase, users who have signed up on your online shop, and information about the orders you receive. You would store the information separately in the database using something called tables. The tables are identified with a unique name for each one. You can see the structure of the diagram below, but you can see how a business might separate database to store staff information and account. So you can see it visually. There is a main database server. There are different databases, and different databases have different tables called users, products, orders table, and the tables contains rows and columns. This stuff will contain rows and columns. Each table have its own rows and columns. Rows and columns. Okay. So this is the thing. What are tables? A table is made up of columns and rows. Useful way to imagine a table is like a grid with the columns going across the top from the left to right, containing the name of the cell, and the rows from the top to bottom, with each one having the actual data. So the thing that goes to left to right is, I think this is horizontal is rows, columns, and the vertical one is rows, columns. Each column, better referred as to as a field, has a unique number per table. When creating a column, you also set the type of the data it will contain. Commons one big integers, numbers, string, standard text, or dates. Some databases can contain more complex data such as geostatistics, geospatial, which contains location information. Setting up the data type also ensures that incorrect information isn't stored, such as a string hello world being stored in a column meant for dates. If this happens, the database server will usually produce an error message. A column containing an integer can also have an auto increment feature enabled. This gives each row a unique number that grows increments with each subsequent row. Doing so creates what is called as a key field. A key field has to be unique for every row of data, which can be used to find the exact row in SQL queries. Rows. Rows or records are what contains the individual lines of data. When you add data to a table, a new row record is created, and when you delete a data, row or record is removed. Relational versus non-relational database. A relational database stores information in table, and often the tables have shared information between them. We use columns to specify and define the data being stored, and rows actually store the data. The tables will often contain a column that has unique ID, primary key, which will then be used to in other tables to reference it and cause a relationship between the tables, hence the name relational database. Non-relational databases, something called NoSQL, on the other hand, in any sort of database that is doesn't use tables, columns, and rows to store data, a specific data type database doesn't need to be constructed. So each row data can contain different information, which can give more flexibility over relational databases. Some popular database types are MongoDB, Cassandra, and Elasticsearch. I'm gonna say which acronym software. What is the acronym for the software that controls the database? So it is DBMS. You just saw that. What is the name of the grid-like structure that holds the data? So it's table. And yep, correct. Let's go to the task 3. Is what is SQL? SQL is a feature rich language used for querying databases. These SQL queries are better referred to as statements. The simplest of the commands which we'll cover in this task is used to retrieve, select, update, and insert and delete data. Although somewhat similar, some databases servers have their own syntax and slight changes to how things work. All these examples are based on a MySQL database after learning the lessons. You will easily be able to search for alternative syntax online for the different servers. It's worth noting that SQL syntax is not case sensitive. The first query we'll learn is the select query, used to retrieve data from the database. So this is the query here, select everything from users. So we already saw that in previous labs and our examples. Okay. The first word tells the database we want to retrieve some data. The star tells the database that we want to receive back all columns from the data table. For example, the table may contain 3 columns: ID, username, and password. For users, tell the database we want to retrieve the data from the table named users. Finally, the semicolon at the end tells the database that this is the end of the query. The next query is similar to the above, but this time instead of using the star to return all columns in the database table, we are just requesting the username and password field. We are selecting here select username and password from users. The following query, like the first, returns all the columns using the star selector wildcard, that is a star, and then the limit 1 clause forces the database to only return one row of the data. Changing the query to limit 1.1 force the query to skip the first result, and then limit 2.2 comma 1 skips the first two results, and so on. You need to remember that the first number tells the database how many results you wish to skip, and the second number tells the database how many rows you want to return. Okay. Lastly, we are going to utilize the where clause. This is how we can finally pick out the exact data we require by returning data that matches our specific clauses. Select star from users where username equals admin. We have already saw this in our Portugal lab. So only admin will be returned here. This will only return the row that where the username is equal to admin. Next, select star from users where username is not equal to admin, not operator. This will only return the rows where username is not equal to admin. Select everything from users where username equals admin or username equals John. This will only return the rows where the username is either equal to admin or John. Select everything from users where username is admin and the password is the password specified. This will only return the rows where the username is equal to admin and the password is equal to password, that is the 4 in between. Using the like clause allows you to specify data that isn't an exact match, but instead either starts, contains, or ends with certain characters by choosing where to place the wildcard character represented by a %sign. Select star from users where username like A. Let me explain this. This is saying like username is like the first character of username is A. So the first character of is admin, so it will return the admin here. If I say the first two characters and keep on typing, it will just give us the result here. Okay, we're gonna see this. We are seeing this in the further lab below the next task. Select everything from users where username like %n. The last character is n, so it's gonna return every username that ends with an n here. This returns any rows with username ending with the letter n. Select everything from users where username like mi will return anything that contains any username that contains mi. So only admin is the one, so it return admin here. This returns any rows with a username containing the character mi within them. Union statement. The union statement combines the result of two or more select statements to retrieve data. For either single or multiple tables, the rules of this query are that the union statement must retrieve the same number of columns in each select statement. The columns have to be of a similar data type and the columns order has to be the same. This might sound not very clear, so let's use the following analogy. Say a company wants to create a list of addresses of all customers and suppliers to post a new catalog. We have one table called customers with the following contents. There is ID, name, address, city, and postcode. And another called supplier with the following content. So ID, company, address, city, and postcode. Using the following SQL statement, we can gather the results from the two tables and put them into one result set. Select name, address, city, postcode from customers. Union select company, address, city, postcode from suppliers. So okay, union also already allows us to combine two statements. So we are selecting name, address, city, postcode from customers and selecting company, address, city, postcode from suppliers. So this will here be the output. The insert statement tells the database we wish to insert a new row of data into the table, into users. Tells the database which table we wish to insert the data into. Username, comma, password provides the columns we provide and the data, then values. Bob, comma, password provides the data for a previously specified columns. So insert into users, username, comma, password, and the values are Bob and password 123. So this statement is used in register user functionality of web application. So when you register, there is new entry created using an insert statement into the database. Update. An update statement tells the database we wish to update one or more row of data within a table. You can specify the table you wish to update using update table name set and then select the field or fields you wish to update as a comma separated list such as username equals root, password equals pass123. Then finally, similar to the select statement, you can specify exactly which rows to update using the where clause such as where username equals admin. So this functionality, this SQL statement is used when you forgot the password and you need to change the password. So you will type in the username, then you will receive a mail to change the query here. Okay. And yep, select users, set username of root and password to 123 where username equals admin. Okay. So you can see here the previous one was admin and password. So we just changed the admin to root and password to 3 here. Okay. So both username and passwords are changed, but the ID remains same. Delete. The delete statement tells the database we wish to delete one or more rows of data apart from missing the columns you wish to be returned. The format of this query is very similar to the select. You can specify precisely which data to delete using where clause and the number of rows to be deleted using a limit clause. So delete from users where username equals Martin. So here Martin will be deleted. Okay. So this is used when you delete an account on any website. So to remove the query, to remove the data set of your account, the delete statement will be carried out in the SQL database. Because no where clauses was being used in the query, all data is being deleted in the table. Okay, let's answer the question below. What SQL statement is used to retrieve data? So select the answer. Let's try. And yep, it's correct. We select the table first and to retrieve the data. Okay. Which SQL clause can be used to retrieve data from multiple tables? So it's union allows us to retrieve data from multiple tables. What SQL statement is used to add? So it's insert used to add data into the database. Okay, let's over to the task 4, which is what is SQL injection? Okay, I'm gonna start the machine here first so that it starts and let's go back here. Okay, and do this. No, okay, let it start here. So what is SQL injection? The point where in a web application is using SQL can turn into SQL injection is when user provided data gets included in the SQL query. What does it look like? Take a following scenario where you have come across an online blog and each blog entry has unique number ID number. The block entries may be either set to public or private depending on whether they are ready for public release. The URL for each blog entry may look something like this. Okay. From the URL above, you can see that the blog entry has been selected comes out from the ID parameter in the query string. The web application needs to retrieve the article from the database and may use an SQL statement that looks similar, something like the following. Select everything from blog where ID equals 1 and private equals 0 and limit the entry to be retrieved to 1. For, from what you have learned in the previous task, you should be able to work out that the SQL statements above is looking into the block table for an article that the ID number of 1 with a private column set to 0, which means it's able to view by the public and limits the results to only one match. As was mentioned as at the start of the task of SQL injection is introduced when users input introduced into the database query. In this instance, the ID parameter from the query strings is used directly to the SQL query. Let's pretend article ID2 is locked and as private, so it cannot be viewed on the website. We would now instead call the URL. This one SQL injection, we are ending the statement here and just commenting out rest of the part. So you can see we select everything from block where ID equals 2. This is semicolon which is used to end an SQL statement and commenting rest of the part. So the new query will be this one. Okay. The semicolon in the URL signifies the end of the SQL statement, and the two dashes used everything afterwards can be treated as comment. By doing this, you are just in fact running the query, which will return the article with an ID2, whether it is a set to public or not. This was just one example of SQL injection vulnerability of the type called in-band SQL injection. There are three types in total: in-band, blind, and out-of-band, which we'll discuss in next task. So what signifies end of the query? So it's semicolon here. And let's go to the next task. In-band SQL injection. An in-band SQL injection is the easiest type to detect and exploit. In-band just refers to the specific method of communication being used to exploit the vulnerability and also receive the results. For example, discovering an SQL injection vulnerability on the website and then being able to extract data from the database to the same page. Error-based SQL injection. This type of SQL injection is the most useful for easily obtaining information about the database structure as errors. Messages from the database are printed directly to the browser screen. This can often be used to enumerate a whole database. Union-based SQL injection. This type of injection utilizes a SQL union operator alongside select statement to return additional results to the page. This method is most common way of extracting large amounts of data via a SQL injection vulnerability. Let's go through the practical. Click on the start machine here. Level 1 of the practice lab contains a mock browser and website featuring a block with different articles, which can be accessed by changing the ID number in the query string. Key to discovering error-based SQL injection is to break the SQL code using we already saw we have to break the SQL query to get an error from the SQL query so that the web application confirms that it's injected there. Okay. Try typing an apostrophe after the ID 1. Here I'm gonna type in ID apostrophe here. Press enter. And you can see here SQL query which is running on the back end, and you can see here the error. So I'm just gonna comment out rest of the part and run enter. Okay, still error. So let's do a space. Okay, still error because it's still breaking the query and there is no query after that. So as it is an integer, okay, let's go ahead. So that it signifies that we can directly use union statement without breaking the query and just retrieve the data. So let's go to the key of discovery. Let's see. So the first thing we need to do is return data to the browser without displaying an error message. Firstly, we'll try to union operator so we can receive an extra result of our choosing. Try setting the mock browser's ID parameter to 1 and union select directly 1 and type in enter, so it will receive an error message. Statements have different number of columns, so I'm going to just type in 2 here till it says these are not the exact number of columns. Type 3. Yep, you can see here there are three columns. Let's go down. Success, the error message has gone. The article is being displayed, but now we want to display our data instead. So I'm going to just say the ID equals 0 here so that the ID data is not returned, and you can see the outputs reflected here. You will now see the article is just made up of the result from the union select, returning the columns values 1, 2, and 3. We'll start using these returned values to retrieve more useful information. First, we'll get the database name that we have access to. So I'm going to just type in here database column brackets, get the database name, and you can see we are using the SQLi 1 database. You will now see here the number 3 is previously displayed. It shows the name of the database, which is SQLi1. Our next query will gather the list of tables that are in the database. Okay, they are using union select. We are concatenating the table name from information schema.table, where the table schema equals to the 1. Okay, let's try in this query. Put in here and try. You can see the query here. So there are two tables, articles and staff users. There are a couple of new things to learn in this query. Firstly, the method group concat gets the specified column in the our case table name from multiple return rows and put it into one string separated by commas. The next thing is information schema database. Every user in the database has access to this, and it contains information about all databases and tables the user has access to. In the in this particular query, we are interested in listing all the tables in SQL1 database, which is article and staff users. As the first level aims to discover Martin's password, the staff users tables is what is of interest to us. We can utilize the information schema database again to find the structure of this table using the query below. So it's concatenating now the column name from information schema.columns where the table name equals staff users. So let's copy in this command that we don't have to type in again. So you can see there are three columns now: ID, username, and password. This is similar to the previous SQL query. However, the information we want to retrieve has changed from table name to column name. The table we are querying in the information schema database has changed from tables to columns, and we are searching for any rows where the table name column has a value of staff users. The query results provided three columns for the staff users table: ID, password, and username. We can use the username and password columns for our following query to retrieve the user's information. Okay, union select, group concat. So we have selected username separated by colon password with a separator of br. This is an HTML tag, and from staff users. So we are selecting this. Let's type in this command here, and you can see admin has password, Martin has this, and Jim has the password work123. And we use the group concat method to return all the rows into one string and make it easier to read. We have also added the colon to split the username and the br tag that forces each result in the separate line. Okay. Now we have access to Martin's password. Enter to get into the next level. Let's type in the Martin's password here. Copy, check password, and yep. What is the flag after completing the level 1? So this is the flag here. Copy this and paste it here. Okay. Let's go to the task 6. Blind SQLI authentication bypass. Blind SQLI, unlike the in-band SQL injection, where we can see the results of our attack directly on the screen. Blind SQLI is when we get a little no feedback to confirm whether our injected queries were in fact successful or not. This is because the error message has been disabled, but the injection still works regardless. It might surprise you that all we need is that a little bit of feedback to successfully enumerate a whole database. Authentication bypass. One of the most straightforward blind SQL injection techniques is when bypassing authentication methods such as login forms. In this instance, we aren't that interested in retrieving data from the database. We just want to get past the login. Login forms are that are connected to the database from users are often developed in such a way that the web application isn't interested in the content of the username and password, but more whether the two are a matching pair in the users table. In basic terms, the web application is asking the database, do you have a user with the username Bob and the password Bob123? And the database replies either with yes or no, true or false. And depending on that answer dictates whether the application lets you proceed or not. Taking the above exam information into account, it's unnecessary to enumerate a valid username password pair. We just need to create database query that replies with yes, true, practical. Let's level 2 of the SQL injection example show exact. We can see in the box labeled SQL query that the query is of the database followed is the following. Here you can see the query. Select everything from user where username is provided here, and the password will be this here, and limit the output to one row. The username and password values are taken from the login fields and initial SQL query. Okay, to make this query to make into this query always return true, we can either following we can enter this following into the password field. Okay, we have already tried. Let's try into the username field, or when equals 1, end of the SQL query here. You can see it's ended here, and let's type in any password. Doesn't mean anything to us. Let's type in don't save. Okay, you can see here you have bypassed the login and can now move to the next level. You can see that we successfully bypassed, and they did even say you can type this into the password field, but we bypassed using the username here, or when equals 1, using our method, which turns the SQL query to the following here. So they use the password example and we use the user example. So let's go to the level 3 and let's paste in the flag here. Okay, let's go to the task 7. Blind SQLI based Boolean based. Boolean based SQL injection refers to the response we receive back from our injection attempts. It could be a true or false, yes or no, on or off, one or zero, or any response, which only have two outcomes. The outcome confirms that to us that our SQL injection payload was either successful or not. On the first inspection, you may feel like this limited response can't provide much information. Still, in fact, with just these two responses, it's possible to enumerate a whole database structure and contents. This is a practical one. Okay, so this is a taken equals to thing. There is no SQL query for this. All right. So the browser contains the taken equals to. The API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt the user to choose a different username. Because the taken values is set to true, we can assume that username admin is already registered. In fact, we can confirm that by changing the username in the mock browser's address bar from admin to admin123, and upon pressing enter, you will see the taken values taken has now changed to false. SQL query that proceeds the following. You can see here it's checking whether the username is taken or not. So I'm going to type in a test. So the username is not taken. So if I type in here my team, which we used, still not taken. So I think it's different database here. If I say admin, so the database is taken here. You can see the query, it's visible now. As the only input, we have control over the username in the query string. We'll have to use this to perform our SQL injection, keeping the username as admin123. We can start appending to this and try to make the database confirm true things, which will change the state of the taken field from false to true. Like in previous levels, our first task is to establish the number of columns in the user's table, which we can achieve by using the union statement. Change the username value to the following. Yeah, okay. Colon 123, which doesn't matter. It's gonna return false. Type in here. So it's returning false here. As the web application has responded with the value taken as false, we can confirm that it is the incorrect value of columns. Keep on adding more columns until we have taken the value of true. Let's try in here. One more column. No. Okay, one more column. Yes. So there are three columns in total. And this is the true statement. So it has returned true here. The union select 1 to 3 worked. Now that our columns have been established, we can work on the enumeration of database. Our first task is discovering the database name. We can do this by using a built-in database method and then using a like operator to try to find results that will return a true status. Try the query below. Here, union is selecting our three columns where database is like. Okay, let's try. Query here. So it's returning true here as the database has a name. So if I say if the database starts with A, it's returning false. If the database starts with B, it's returning false. So if the database starts with S, and it's returning true. As we already know, it's SQL I something. Yep, something one or some. Let's see. We get the true response because in the like operator, we have the value of percent, which will match anything as it's the wildcard value. If we change the wildcard operator to A, you will see the response goes back to false, which confirms that the database name does not begin with the letter A. We can cycle through all the letters, numbers, and characters such as underscore until we discover a match. If you send the below as the username value, you will receive a true response that confirms the database names begin with S here, right? And there is something. So they have said that the database name is SQL3 is returning true. So we can confirm that the database name is SQL underscore 3 here. Okay. We have established the database name, which we can now use to enumerate table names using a similar method by utilizing the information schema tables by setting the username to the following value. Okay, it's union selecting the three columns from information schema.tables, where the table schema equals the database name and the table is like, and we have to enumerate. You can also send this to pop into the write this one by one, all the alphabets, all the numbers, all the symbols. And after you get it, the first one, you can try another one and another one until you get the table name. Okay. For our convenience, they have already provided the table name. Save some time here. Okay. If I press enter, it's saying false. Let's see. This query looks for results in information schema databases. In the tables where the database name matches SQLi3 and the table name begins with the letter A. As the above query results in the false response, we can confirm that there are no tables in the SQL3 database which begins with the letter A. Like previous, you will need to cycle through the letters, numbers, characters until you get a positive match. You finally end up discovering the table in the SQLi underscore 3 database named users. Okay, let's type in here U. It should result in true. So there is a table that starts with the alphabet U and it returns true. If I type in here users and the output is true, so we can confirm that there is a table named users. You finally, okay, and let's type to get the data now. So yeah. Lastly, now we need to enumerate the columns name in the data in the users table. So we can properly search it for login credentials. Again, using the information schema database and the information we have already gained, we can start querying it for column names using the payload we search and columns tables where the database is equal to SQLi3, the table name is users and the column name begins with A. So it's doing again union select our three columns from information schema.columns where the table name is SQL underscore 3 and the table name is users and the column name starts with A. So let's try this query. Let's paste it in here. Does the column name starts with A? It's returning false. Does it start with B? It's returning false. So let's see. If it starts with I, it's returning true. So that means there might be a column called ID. Yeah, okay. Again, you will need to cycle through letters, numbers, and characters until you find a match. As you are looking for multiple results, you will have to add this to your payload each time you find a new column name. So you don't keep discovering the same one. For example, once you have found the column named ID, you will append that to your original payload as seen in below. Okay, once you have found there is a column named ID, we need to find another column. Okay, so we will say yeah, union select 1 2 3 Three columns from information schema dot columns where the table name equals table schema equals actually I misspoke here too. The table schema equals SQLi underscore tree, and the table name is users. The column name starts with A, and the column name is not equal to ID. Okay, so it's ignoring the ID column, and we can enumerate the second column. So it might be username as far as we know. It's false. If I say here you, it's true. So username, and these are common database name like username, ID, password, tracking ID, and these are all default column that every developer put into the database. Okay, so it's quite guessable, you know. Repeating this process 3 times will enable you to discover column ID, username, and password are 3 columns, which now you can query the user's table for login credentials. You will need to discover a valid name, which you can use a payload below. So here, union select from users, where the username is like A, starts with A. So it might be referring to admin username that we already saw. It starts with A. Does it start with B? Okay, let's start try to our ending one too. So I will say here, if it ends with, so admin ends with N. So if I say it ends with N, it will return true here. So there is a username admin. If it ends with anything else, it will return false. Okay, and let's try a middle one too. Okay, the admin has mi in middle. So if I say here, if the username has mi in middle, it will return true, and if something I type in here random, it will return false. Okay, delete this, and if it starts with A, if it has D in it, and it's admin here. Okay, true. Which once you have cycled through all the characters, you will now confirm that the existence of the username admin. Now you have got the username. You can concentrate on discovering the password. The payload below shows you how to find the password. Here, union select all 3 columns from users where the username equals admin and password starts with A. Okay, I paste it in here. The password starts with A. So they have already given us the password, so it's starting with 3. If I say here 3, it's true. The password is 3845 and it's returning true here. Cycling through all the characters, you will discover the password is 3845. You can now use the username and password to log in here. So I'm going to admin 3845 login, and I think we are logged in here. Let's type in the flag, paste it in here, and yep, it's correct. So let's go to the task 8, time-based blind SQL injection. A time-based SQL injection is very similar to the above Boolean-based in that the same requests are sent, but there is no visual indicator for your queries being wrong or right this time. Instead, your indicator is of the correct query is being on the time the query takes to complete. This time delay is introduced by using a built-in method such as sleep alongside the union statement. The sleep method will only ever get executed upon success union select statement. So for example, when trying to establish the number of columns in a table, you would use the following query here. Type in here. So for a try hack me, okay, if I type in single quote, it's returning okay. So there is blind one. Okay, I think it's not commenting out the rest of the part. Select, and I think there are more than two columns here. Type in 2 here, and I think it's waiting for 5 seconds. And yep, you can see here it waited 5 seconds to send the response, as we have told here to sleep for 5 seconds. So if I say sleep for 10 seconds, it will wait 10 seconds to send the response back to the server. Okay, let's see here. If there was no pause in the response, we know that the query was unsuccessful. So like the previous task, we add another column. The payload should have produced a 5-second time delay, which confirms the successful execution of the union statement. That and that there are two columns. You can now repeat the enumeration process from the Boolean based SQL injection, adding the sleep method into the union select statement. If you are struggling to find the table name, the below query should help you on your way. Okay, there is a referrer, and type in here. It says, okay, so the database doesn't start with U, it starts with S. Yep, it starts with S. Okay, after, if you're struggling to find the table name, name the below query should help you on your way. Yeah, answer what is the final flag after completing the level 4 here. Okay, I think we are okay. Let's enumerate the table name here, SQL. Let's do the time delay as 2 so that we get a quick response SQL underscore 3. Actually, it might be 4 because the level is 4. It's okay. No, it's not 4. 3, not 3. It has a underscore below. Okay, you can now repeat the enumeration process. If you are struggling to find the table name, below query should help you on the way. So we need to complete the table name. So I think we will skip this level. I hope you understood. You can use the burp intruder. We have the slow version of burp intruder, so we are gonna not do that. So let's guess here. A, no B, C, no D. Let's type in here. H I J K L M N. I am brute forcing this manually. Yeah, I think it's F4. No, I think you should actually do the thing after that, and I think you should be there. So I think if I say here, is this the answer? What did we say the answer is? No, I think it's not the answer here. Okay. So I'm gonna skip this for you. I hope you do it using the burp intruder. And yep, let's go to our out of band SQL injection. Out of band SQL injection, it's as common as it either depend on a specific feature being enabled on the database server or the web application business logic, which makes some kind of external network call based on the results from the SQL query. An out of band attack is classified by having two different communication channels, one to which the attack and the other to gather the results. For example, the attack channel could be a web request, and the gathered channel could be a monitoring HTTP DNS request made to the service you control. An attacker makes a request to the website vulnerable to SQL injection. With the injection payload, the website makes an SQL query to the database, which also passes the hacker's payload. The payload that contains the request forces the HTTP request back to the hacker's machine. Okay, so hacker is sending some malicious payload to the website. The website will query to the database, and database is forced to query the hacker's website. Here, okay, name the protocol beginning with D that can be used to exfiltrate data from the database. So it's DNS, and yep, that's correct. Remediation. As impactful as SQL injection vulnerabilities are, developers do have a way to protect their web application from them by following the below advice. Prepared statement with parameterized queries. In a prepared query, the following thing a developer writes is the SQL query, and then any user's input that are added as a parameter afterward. Writing parameter statements ensure that the SQL code structure doesn't change and the database can distinguish between the query and the data. As a benefit, it also makes your code look a lot cleaner and easier to read. Input validation. Input validation can go a long way protecting what gets into the SQL query. Employing an allow list can restrict input to only certain strings or a string replacement method to the programming language can filter the characters you wish to allow or disallow. Escaping user's input. Allowing a user's input the characters such as quote, double quote, dollar, and backslash can cause SQL queries to break, or even worse, that we have learned, open them for injection attacks. Escaping from user's input in their method of pretending the backslash to these characters, which then uses them to be just passed just as a regular string and a special character. So a developer can blacklist this character in username, password, or any fields that are passed into the SQL query. So name the method protecting yourself from an SQL injection exploit. It's prepared statement. And yep, that's correct. Okay. So I think we have completed this whole room. And for this part, I'm going to attach this as after I complete this because the video is already 1 hour long and Udemy doesn't like long videos. So I'm gonna just do this in burp intruder and just will make a separate video or just give the answer to you guys, okay, so that you can paste the flag in here and complete the room. Okay, that's all for this video. I hope you understood. It was a quite a bit long video and I hope you followed up here till now. And in the next video I'm going to do a walkthrough of the SQL map tool, which is the most advanced tool to exploit SQL injection automatically, which even detects SQL injection in parameters. Okay, that's all for this video. I hope you enjoyed. See you in the next video. Bye.